Imagine being able to automatically migrate any virtual machine in your local private network to a public cloud. Any public cloud. And then back again. We have the opportunity to look inside a world-class data center and see how Cisco has built a truly modern, application-centric data center that can securely scale privately, publicly, and everywhere in between. This facility is the premier showcase for showing how Cisco's Intercloud can accelerate the benefits of a truly nimble hybrid cloud.
The data center that we have here in Allen, the private cloud that it supports, is really a foundational building block for us to be able to operate our business.
Most businesses are implementing hybrid cloud because it gives you the ability to run a certain amount of your resources on a private environment and then only burst to a public environment. It's really just a matter of where you put your workloads.
What we're doing is we're automating all these processes. We're making those processes such that they're repeatable, they're easy to understand, and they're reusable at all points.
Cisco Intercloud Fabric enables secure hybrid clouds by extending the existing data center to public clouds automatically.
IT nowadays has to be really fast, really agile, and really efficient.
Well, this is the freedom to augment capacity on demand. So how do we approach this? It was just 2010 when this site was chosen as Cisco's first owned data center built from the ground up. The Domain 10 framework was developed by the Cisco Services Organization as a map for building a complete data center, a logical set of building blocks that include governance, security, and scalability goals, along with those often forgotten disciplines that will ensure our ability to deliver on all of these. All good buildings start with a good foundation, so let's start with the environmentals. These solid floors mean no weight requirements. This space can grow and modify however you need. It also means that some of the most interesting stuff is happening above us.
Cold air will come into the front of the cabinets. We have perforated panels on the front of those cabinets. The cool air is drawn in. The hardware does the magic that it does, generates hot air out the back, which naturally rises up through the chimney. It's an entirely passive system. We get this natural air stratification. We take advantage of the fact that the cool air is going to fall, the hot air is going to rise, and we can let it exit out of the building if we don't want to use that hot air. For those times where we want to make use of some of that exhaust heat, we can recapture it and bring it back into the space. If you look at how we're cooling the systems in our data center, we'll collect air from the outside. We actually have these 3 rectangular structures on our rooftop that we call our dog houses because they look a little bit like dog houses. Airflow will pass by into those containers, directed into a corridor that runs through the center of our building. We have louvered panels that back up to each of the air handlers that feed into our equipment. When our temperature sensors indicate that we're in this ideal cooling and humidity range, those panels will gradually open up, draw that air in through each of the air handlers. The handlers themselves have multiple layers of filters with a fan at the far end, draws the air through, cleaning it. The air is then pushed up into this overhead plenum space that's above the data hall, and then that cool air naturally falls into the cold aisles. When we're outside of that ideal temperature and humidity range, those panels gradually close and we go back to using the condensers in our own system.
So how much air are we talking about? Up to 1.5 million cubic feet per minute. That's enough to cool almost 4,000 family homes. It's a lot of air. But when your voltage comes in, you're usually going to have some ripples in it, which is really bad news for those ones and zeros. So to keep things smooth, most data centers use static UPS systems with rows of high-maintenance lead-acid batteries. Well, batteries get weaker over time. They've got memory issues, and you end up having to aggressively rotate them. This is a dynamic rotary UPS. It uses a flywheel to provide power through any momentary drops in quality.
Utility power comes in, spins that flywheel, builds up the kinetic energy. If you lose that utility feed, That spinning wheel provides enough energy temporarily to support the load until it can be transitioned over to the generator.
Two of the most interesting areas within the infrastructure here include Cisco's Unified Computing System and the application-centric infrastructure. Well, Cisco's Unified Computing System, or UCS, is a server architecture providing a flexible pool of compute resources. Three specific innovations within UCS enable unique support for applications. First is a truly unified fabric, which eliminates the need for distinct network infrastructures. Network complexity goes away as your storage area network connects directly to adapters within the UCS fiber interconnects. The UCS Manager is a single location for all management of the LAN, SAN, server, hardware, and chassis, which are pulled into the access layer. By doing this natively in hardware, this provides a very rapid, repeatable, physical server deployment model similar to what made virtual servers so attractive. And all of that out-of-band management simply goes away. But UCS is also stateless. A workload is not defined by the blade or the slot on which it resides. And this provides an incredible freedom for applications through the use of service profiles. These profiles define what a server is and how it operates. A portable identity defined in a simple configuration file so a server workload can quickly move from one physical blade to another with no changes in the network or the storage arrays. Install the server, apply the service profiles, and within minutes, the server that matches your requirements is ready for use with policies intact and ready for the network. That network is the application-centric infrastructure, or ACI, which takes profiles to yet another level. Application network profiles define how an application will look, connect, and be treated anywhere it goes on the network. Applications are far from singular entities. Even simple ones will usually be a combination of web, application, and database tiers that could all be running in different physical environments. ACI allows us to group applications by common characteristics such as connectivity and policy requirements, where location becomes completely irrelevant. Policy can now be defined using business-relevant terms and one simple interaction point. The Application Policy Infrastructure Controller, or APIC, uses these profiles to create logical topology and policy definitions on top of this stateless hardware. Nexus 9000 hardware provides visibility, statistics, monitoring, and telemetry of everything that is happening throughout the fabric of the data center. The leaf spine layout enables linear scalability with every spine switch creating another network path available for load balancing. This is a layout that is ideal for that east-west traffic by offering layer 2 adjacency on any path. The APIC also ensures an open future by exposing a northbound API for access to all of the control functions and a southbound API for third-party network services. ACI is software flexibility with the scalability of hardware. Here in the Allen Data Center, they are now running over 4,000 production applications on the ACI fabric.
Almost every bit of this impressive facility, the infrastructure and the environmentals, remain invisible to the very users it serves. The combination of abstraction and virtualization make cloud computing possible. Virtualization is just one early step towards scale and workload mobility. Ignoring domains above or below here will only increase your risk. The orchestration function controls the virtualization domain. Automation is where we streamline repetitive processes and drastically reduce provisioning time. Orchestration then links these automated tasks together to provision a new service. There's a lot of great stuff to investigate here, but for our purpose, it is but a foundation for two areas that I want to share: the self-service customer interface and workload automation. Cisco's IT Elastic Infrastructure Services, or CITES, is more than infrastructure as a service cloud, but it also provides platform as a service capabilities as well, including the delivery of a complete environment for application hosting, development, testing, and deployment.
Rather than people trying to deploy a physical box that could take 10, 12 weeks or more, they request an instance. It can be provisioned in 15 minutes or less.
Well, ease of use is key to providing a consumer-type IT experience to internal users while still maintaining governance and control over the infrastructure by IT. And Cisco IT has been doing this for years.
From an IT perspective, the user is doing their own provisioning. This is a no-touch environment that really reduces the cost, and it just simply makes it very fast for end users.
Well, when users get this from IT, they have no reason to go outside. There is a director on the enterprise side providing a console for users and IT admins, enabling self-service consumption and policy management. The provider platform is a virtual appliance deployed and managed by the public cloud providers. And then finally, the connectivity piece is the secure cloud extender, creating the encrypted connectivity between clouds with full layer 3 through 7 services.
So UCS is your local server, ACI is for your local network. Now we're going into cloud, which is your wide area network. So we're taking it from the private cloud in your own data center and putting it out to public services.
The Intercloud-enabled data center can expand and contract with any resources needed to provide the requested service.
Now what we want to see is that control coming back to IT within our own organization.
Intercloud is really the ability to move your workloads to the place that makes the most sense.
But Intercloud also allows you to bring that workload back again, very, very simply. Now what we're doing with ACI, with UCS, is we're given the ability to actually generate those workloads very, very quickly and on demand. And that allows the control to come back into IT. It allows us to take over the security, the connectivity policies to protect the data that you're generating.
The Intercloud catalog can provide a cloud services marketplace. Costs can be verified and tracked for internal forecasting or billing. Making the purchase is simply a click, and then the user can keep shopping or move right into a configuration of their new service. So now, what can you do with this information? First off, where are you today? And what is your organization's true spending on cloud? And not just within IT. This is crucial for forming any kind of a cloud strategy.
Cisco Cloud Consumption Service gives you the ability to find out how many different workloads do you have on different public cloud providers.
The second one would be around private cloud elasticity. How much or how little can you handle in-house? Because that's going to lead to number 3, which is your public cloud strategy. How can you efficiently scale that same capacity through a public cloud partnership, but do it right now?
If you can build a cloud that gives users that same speed and ease of use, well, your users are going to stay on your infrastructure.
Number 4 is hybrid cloud readiness. Do you have a hybrid cloud strategy that will work within your policy model?
We're giving you the ability to optimize your network as to how these work services move between different elements of your network, your web servers, your databases, all those sort of things within your IT network.
And number 5, streamlined service delivery. How automated are you at this point?
The marketplace you can think of as the App Store for enterprise applications.
Well, we are here to help you take advantage of the cloud. All of them. Perhaps a world-class data center with the visibility, control, coupled with the infinite scale of the Intercloud fabric.